Okay, so our next example is about cost and revenue. So in business, the point where the company's costs equal its revenue is called the break-even point. All right. So we're going to say, well, let's let C of X, be represent the production cost in dollars of X units of whatever product this company is making. We're going to let R represent the revenue in dollars from the sale of that many units, and we want to know how many units must we produce and sell in order to break even. So we're given the two equations here. The cost is 8.5 times X plus 75. The revenue is 10X. So obviously it's costing us $8.50 to make each unit, and we're selling it for $10. So now in this case, we want to know where C and R are equal, so we could call those temporarily, we could call those Y. So we want these equal. Now, so there's two ways to solve this problem, right? One, we can just say, hey, what is 8.5x plus 75? When is that equal to 10x? And honestly, this is the easiest way to go. It's going to be equivalent to setting this up as a system of equations in X and Y, because we want cost to equal revenue, so we can use Y for both of those. And then we could say, well, I'm going to subtract the second equation from the first. I'm going to get 0. 8.5 minus 10 is going to be negative 1.5x, and 75. So we've got 1.5x equals 75. So x will be whatever 75 over 1.5 is. So 100, now let's try that again. 75 divided by 1.5, 50. So we should have to sell 50 units. Now if we go to our original inclination, which is also correct, we could say, hey, I'm going to subtract 8.5x from both sides. I'm going to get 75 equals 1.5x. Oh, look, that's exactly the same equation that we arrived at previously. Okay. So we'll do, since that one was short, we'll do a 2-in-1, and we'll do our last example, which is everybody's favorite, boats in a stream. Right, so Justin's boat here travels 208 kilometers downstream in 5 hours, and it travels 203 kilometers upstream in 7 hours. So we want to find the speed of the boat in still water and the speed of the stream's current. So one thing we got to remember is, that distance equals rate times time. So that's an important equation that kind of is assumed to be known here. And so if we say when he travels downstream, his rate is his boat's rate. So let's say B is the boat rate and R is the river rate. So when he's traveling downstream, then that means his total rate is the sum of his boat plus the river rate. And he travels that in 5 hours, so that's our time. And he travels a distance of 205 kilometers. Upstream, he's got his speed, right? But the river is now acting against him, so it's going the opposite direction. His time is 7 hours, and his distance is 203 kilometers. So there's our equations, and from here, if we want to solve, 5b plus 5r equals 205, and 7b minus 7r equals 203. Your choice of, actually, you know what, it would have been easier, let's do that, easier to divide at least the first equation by 5, right? 205 divided by 5 is going to be 41. So we can say b plus r equals 41. And then I want to see if 203 is divisible by 7. It is. 203 over 7 is 29. So we just said, hey, let's divide both sides by 5. For the first equation, let's divide both sides by 7. By the second equation, that's going to save us some work. And now we are set up perfectly for elimination. We're going to add our equations. So 41 plus 29, that's going to be 70. So B is going to be 35 kilometers per hour. And of course, now our river, we know that B plus R equals 41. So R is equal to 41 minus our boat speed. So our river is 6 kilometers per hour. And we're done, because that is the last example.